Hello, everyone. All right, so we're starting Unit 6. So Unit 6 is about exponents and polynomials. So we're going to start off with just day one of exponents. So looking at exponents, just to be acquainted with the different parts. So the actual number itself is going to be called the base, whereas the power it is being raised to, that is the exponent. So we're going to look at expanding these first, just to kind of get an idea of what we're doing. All right, so first off, if I have 2 to the third power, that means I'm going to write out 2, that's not a 2, 3 times. All right, so the exponent tells you how many times you're going to write the base. So if I simplify this, 2 times 2 is 4, times 2 gives you 8. All right, so if I have x to the fourth power, that means I'm going to write out x 4 times. Now, because it's a variable, there's really no other simplifying you can do, so x to the fourth is really just x to the fourth. But if we were to expand it, this would be your expansion. All right, so similarly over here, now we have x to the third, or x cubed, and y to the fourth. So what this means is I'm going to write out x 3 times, so x times x times x. Then I want to write out y 4 times. So 1, 2, 3, and 4. So that would be your expansion. All right, and last but not least, 5 cubed, so 5 times itself 3 times. So 5 times 5. And then we have k to the fifth, which means k 5 times. All right, so I'm going to go ahead and simplify 5 cubed. So 5 cubed is 5 times 5, which is 25. 25 times 5, which is 125. So 125 k to the fifth if I were to simplify. Okay, so now looking at exponents, we're going to kind of make sense of what's happening with just the rules in general. So we're going to be looking at several different rules, but we're also going to talk about what negative exponents are and what they mean. So we're actually going to start over here with these positive exponents. So here, if I have 2 to the first power, that's just 2 written out once. If I have 2 squared, that's 2 times 2, which gives you 4. And then if I add on a number, another 2, so here, I'll do this. So 2 times 2, 2 times 2 times 2, which gives you 8. And then 2 times 2 times 2 times 2, which is 16. So if you notice a pattern, we're doubling each time. So every time I go to the right, I'm going to multiply by 2. So if I want to go to the left, that means I would need to do the opposite. So instead of multiplying by 2, the opposite is dividing by 2. So to fill out the rest of the chart, I'm actually going to start dividing by 2. So if I divide by 2, 2 divided by 2 gives you 1. All right, so anything raised to a 0 power is going to be 1. Now, if I have a negative exponent here, I'm going to keep dividing by 2. So 1 divided by 2 gives you 1/2. If I divide by 2 again, you get 1/4. Then you get 1/8 and 1/16. So if you notice, the numbers are actually the same. The only difference is if it's negative, the value is actually in the denominator. So 2 squared, we have a 4. But if I have to the negative second power, it's in the bottom. If I have 2 cubed, our number is 8. But if the exponent's negative, it's in the denominator. All right, so we're going to kind of use some of these rules to put some more information together. All right, so we're going to start with a rule called product property. So with product property, I'm going to start by expanding, and then we're going to look to see if we can discover a rule. So if I have x to the third power, so x times x times x, and then I'm going to write out x to the fifth power. So I want to simplify this. So really what I want to see is how many times I wrote down this x value. Oh, it's going downwards, it's fine. All right, so I wrote x 1, 2, 3, 4, 5, 6, 7, 8 times, which means 8 is going to be my new exponent. So kind of look back over here. If I start off with 3 and 5, how could I end up with 8? So the rule here is I can add those exponents. All right, so with product property, it's going to be x to the a plus b. Whatever those exponents are, you're going to add them, so long as the base is the same. All right, so notice how the base is written more than once here. All right, so looking over here, we have a squared a, b to the fourth, b to the fifth, a cubed. So with this one, notice how this a value here doesn't have an exponent. So if it doesn't have an exponent, you assume the exponent here is 1. So what I'm going to do is I want to combine all the a values together, and then I'm going to combine the b values together. So for my a value, I'm going to add together the 2, the 1, and the 3. So 2 plus 1 plus 3. And then for the b values, I'm going to add those exponents together. So b to the 4 plus 5. So I'm going to simplify. So my new exponent for my a value, 2 plus 1 plus 3, gives you 6. And then my new exponent for my b value is going to be 9. So this would be your simplified answer. All right, now looking at this next one, we have 2 to the fourth times 2 squared. So we have the same base, so I can just add both of these together. So I'm going to have 2 to the 4 plus 2, which is 2 to the 6th power. So is that 64? Yep. All right. So if you multiply 2 by itself 6 times, you should get 64. So 2, 4, 8, 16, 32, 64. All right, so that is with product property. So now we're going to look at another property called power property, or power rule, or product rule, whichever one. So we're going to look at another pattern here. So for the first one, I'm going to start by expanding it. All right, so we have r squared 4 times. So I'm going to write out r squared 4 times. And now I want to expand all those r squareds. So I'm going to have r times r, r times r, r times r, and r times r. So notice here, we have 1, 2, 3, 4, 5, 6, 7, 8 r's. So we're going to have r to the 8th. So you want to notice, how do we go from 2 and 4 to 8? So the rule here is I'm going to multiply the exponents. All right, so up here, x to the a times b, it's going to be our rule here. So notice here how the base is only written once, whereas for product property, it's written more than once. So you really have to pay attention to the parentheses, because on paper, like on a practice or whatever, these rules could look very similar. So you have to be able to distinguish which one is which. So odds are with power property, you're going to have parentheses. With product property, you will not always have parentheses. So that's also kind of a good way to discover. All right, so our next one here, we have w cubed raised to the 5th. So I'm going to multiply 3 times 5. So we're going to have w to the 15th power, because we're multiplying those exponents. Okay, for this next one, these are the ones that tend to be a little bit more tricky. So for these, notice how we're raising everything inside the parentheses to the 2nd power. So what we're going to be doing here is every single base is going to be getting this exponent. So what I mean by that is we're going to pretty much, quote unquote, we're going to be distributing. All right, so we're going to multiply all those exponents according to what the base has already. So the 3 already has an exponent of 2, but then I'm going to also multiply it by 2 based on the exponent from the outside. And then with the k, there's no exponent, so we assume there's a 1 there. And then we're going to multiply it by 2. And then for the y, it has an exponent of -4, but I'm going to multiply it by 2. All right, so now I'm going to multiply and simplify these. So 3 to the 2 times 2, so that's going to give you 3 to the 4th power. And then 1 times 2 gives you 2, so k squared. And then y to the -4 times 2, which gives you -8. So this would be your simplified expression. However, I will say, the next rule we're going to learn deals with negative exponents. So technically there's one more thing that we can do, but I'm going to hold off on that for right now. All right, so now looking at 0 and negative exponents. So as mentioned before, all values raised to the power of 0 is going to be equal to 1. So the reason for that is using this table up here. So right here, anytime you're doing that rule, anything raised to a 0 power is going to give you 1. All right, so if I have 3 to a 0 power, it's 1. If I have x to a 0 power, that's 1. If I have 4xy all raised to a 0 power, that is 1. So no matter what, it's going to be 1. But over here, you have to be careful on these because these are going to kind of trick you up. So notice how this one, everything is raised to a 0 power because of the parentheses. However, on this problem over here, only the y is getting that 0 exponent, which means the 4x are unaffected. So it's going to be 4x parentheses 1, which then is just 4x. So those parentheses can be, they can make a big difference on your problems. All right, so negative fractions must be simplified. Actually, that should say exponents. That should be exponents. So negative exponents must be simplified by making them positive. So in order to make the exponents positive, we are going to flip. So keep in mind, this is only pertaining to negative exponents. So we're not looking at the base really per se. We only care if the exponent is negative. The base can be negative, but we wouldn't switch it. All right, so to start off, we have 3 to the -3rd power. So I'm going to kind of turn this into a fraction just so we can kind of get a better visual. So I'm going to start off with 3 to the -3 all over 1. So because of this negative exponent here, what that tells me is this entire value here is going to go to the other side of the fraction. So if it's in the top, it's going to go to the bottom of the fraction, which means once it switches over, it then becomes positive. So notice how we don't have anything up here in the top. So what that means is we just write a 1. So from here, now we can simplify. So 3 to the 3rd power. So 3 times 3 is 9, times 3 is 27. All right, so similarly, x to the negative 4. So I'm going to start by making it a fraction. So because of this negative 4 here, all of this is going to go to the bottom. So I'm going to have x to the positive 4. So once you switch the side, the exponent sign switches. All right, and then we don't have anything on the top, which means we just have a 1. So our final answer here is just going to be 1 over x to the 4th. All right. Next here, we have 5 to the negative 1/3. No, 5 to the negative 3rd. 5 to the negative 3. English is really hard. All right, so what we're going to do here is we're going to have 5 to the positive 3rd in the denominator. It's going to switch, and then we have 1 on the top. And then 5 to the 3rd power. It's going to give you 1 over 125. All right, so just for everyone's information, either of these answers would be technically acceptable. However, if it's multiple choice on an exam or whatever, either of those answers could be given. So whichever one you choose to provide would be correct. But notice how on an exam, I may only give you, say, the simplified values. So I may only give you like 1 over 125 or 1 over 25 or whatever. So you have to simplify your answers entirely on some problems. All right, next, 1 over 3 to the negative 4. So notice how this time the exponent is already in the denominator. So because it's in the denominator, now I'm actually going to move it up to the top. So I'm going to have 3 to the positive 4. And because I have nothing in the denominator, now it's just over 1. So this is 3 to the 4th. So 3 times 3 is 9, times 3 is 27, times 3 is 81. All right, so looking at this next one here, now we have a couple different negative exponents. But notice here how we have an exponent of positive 2. So what that tells you is that positive 2 exponent there is not going to move. It's going to stay exactly where it is. So I'm going to leave the y squared alone. It's not going to move. However, x to the negative 3rd, that's going to move to the bottom since it's negative and then become positive. And then z to the negative 4, because it's in the bottom, it's going to go to the top. Which means then it becomes positive. So this would be your final simplified answer. All right, so that's the whole idea of the lesson. So the rest of these are really just... All right, so to start the mixed practice, so we have x squared times x to the 4th times y to the 6th times y. So for the y value, since we don't have an exponent here, we're going to assume there's a 1. All right, and then we want to start simplifying by using product property, since the bases are written more than once. So I'm going to combine the x's, and then I'm going to combine the y's. So what's going to happen here is I'm going to have x squared, and then add that 4. Then I'm going to have y to the 6th, and add 1. All right, so based on this, so I'd have x to the 2 plus 4, which gives you x to the 6th, and then 6 plus 1, which gives you 7. So x to the 6th, y to the 7th would be your simplified answer. All right, and then looking here at number 2. So this is product property, but also a little bit of product and power property. So, because notice how on the inside of the parentheses, we have h written more than once. So you can actually start by simplifying the inside of the parentheses before you start working your way out. So I'm going to do product property first. So 4 plus a negative 2, and then j to the 5th. That's all raised to the 3rd. So when I simplify that, we're going to have h to the 4 minus 2, which is h squared. then j to the 5th, all raised to the 3rd. Then you can not simplify, well, simplify, but distribute that 3. So we're going to have h squared times 3, then j to the 5th times 3. So when you simplify, 2 times 3, which gives you 6, then j to the 5 times 3, which gives you 15. So that would be your simplified answer. So one thing to point out, there's not just one single way how to solve these problems. For example, if you wanted to actually start by distributing the 3 to everything and then doing product and if you want to start by doing power rule then product rule, you can. So really what I did is I did product rule then power. If you want to start with power and then go to product, you can. All right, so looking at number 3. All right, so we have negative exponents here. So I'm actually going to get rid of all those first. So in the numerator, we have t cubed. So that's a positive exponent, so that's not going to move. However, both of the denominator values have negative exponents. So both of those are actually going to move to the top. So I'm going to have k to the 5th power, then t to the 3rd power over 1. All right, and then I'm going to combine the t values. So I'm going to have t to the 3 plus 3, then k to the 5th. All right, so I'm going to have t to the 6th power, k to the 5th power. So that would be our simplified value. All right, moving on to number 4. All right, so here, I'm going to start by writing it all over 1. All right, so I have 0 to the negative 5th, so I'm going to move it to the bottom, then it becomes positive. So 0 raised to the 5th power is just 1 over 0. Now, you can't divide by 0, which means the answer here is undefined. Because remember, you cannot divide by 0 without breaking math. Please do not break math. All right, number 5, these should be your easy ones. Everything's raised to a 0 power, which means 1. Just be careful. If there's not parentheses there, then it's not all just going to be 1. All right, number 6. So we're going to start incorporating some just random bases and actual values. So I'm going to kind of rearrange it before I actually do anything first. So what I mean by rearrange is I'm going to move all the values to the very front. So 4 times 3. Then I'm going to put all the x values together. So x cubed times x. And then I have my y value at the very end. So keep in mind, we're multiplying here. So 4 times 3 is going to give you 12. And then I'm going to add the exponents for the x's. So 3 plus 1. And then I have y to the 4th. So this is going to turn into 12x to the 4th, y to the 4th. So that would be your final answer here. All right. Now number 7. All right, so now we have 2/3 x to the 3rd, y to the 5th. So I'm actually going to rewrite this. So notice how these values, if I were to write these as a fraction, everything would be over 1, which means they're going to go in the numerator. So I'm going to write it as 2 x to the 3rd, y to the 5th, all over 3, raised to the 2nd power. All right, so from here, I'm essentially going to distribute the exponent. So everything is going to get an exponent of 2. So 2 to the 1 times 2, x to the 3 times 2, y to the 5 times 2, and 3 to the 1 times 2. So all those exponents are getting multiplied by 2, which means we're going to have 2 squared, x to the 6th, y to the 10th, over 3 squared. So if I continue to simplify this, so 2 squared would be 4, x to the 6th, y to the 10th over 9. So really either one of those would be accepted. Just know either one of those could end up on a test too, whichever answer choice. All right, looking at number 8. So there's multiple ways that you could do this one. You could either simplify the negative exponent or you could do product property. So I'm going to do product property. So I'm going to do e to the negative 4 plus 4. And negative 4 plus 4 gives you 0, which means that would be 1. All right, number 9. All right, so notice how all the bases are A's. However, you can't do product property right off the bat. The reason is because of those parentheses. Once you get rid of those parentheses, then you can do product property, but you have to do power property first. All right, well, I will say here, because these are inside the parentheses, these you can simplify first. All right, so I'm going to do a cubed plus 4 to the negative 2. And then 24 times 1/2. All right, so I'm going to have a to the 7, negative 2. Then a to the 12. All right, so this is going to be equal to a to the negative 14 times a to the 12th. Then I can do product property, so negative 14 plus 12, which is going to give me a to the negative 2nd power. And then negative exponents tell me you have to flip it over. So 1 over a squared is going to be your final answer. So your final answer cannot have any negative exponents. All right. And then down here, all right, so 4 to the negative 3rd power is in the denominator. So because it's negative exponent, you have to switch it up to the top. So 4 to the 3rd power over 1. So 4 to the 3rd power, it's going to be 64. 4 times 4, 16. 16 times 4 is 64 over 1, which means this final answer is going to be 64. All right, and then here with these negative exponent values, or not negative exponent values, but the negative bases, the negative with the base can be kind of confusing. You have to look at the placement in regards to the parentheses. So if you look at both 11 and 12, these are very similar. The only difference is where the negative is, but it does change the problem. So because the negative is outside the parentheses, that tells me the negative is not going to be repeated. So I'm only going to do 2x 4 times, but the negative is only written once on the outside. So I'm going to have negative 16 x to the 4th. All right. However, for number 12, because the negative is written inside the parentheses, that means the negative is going to be repeated as well. All right, so 2 negatives make a positive. There's 4 values, so the final answer is going to be positive. So it's going to be the exact same. Well, close to the same.